Good morning. I'm Jeremiah Bryant, Director of Strategic Development here at Omnitrans. And I'd like to talk a little bit about using data to improve transit and really about understanding trade-offs. We offer a family of services that's really designed to match the service we provide with the needs of the community, and those service levels and the family of service is really a data-driven approach to make sure we're putting the right service in the right place. That family of services includes bus rapid transit lines, which are the SBX Green Line outside of Cal State San Bernardino, a series of local and express routes, paratransit service for ADA qualified riders, microtransit service, which I'll talk about in a little bit, and then special transportation services, which are specialized services for those senior and disabled. What do we use data for? And I think if most people ask me what's data for, I think the most common response that we get about transit agencies really goes to what I think people think our core mission is, which is maximizing transit ridership, looking at big data, looking at all data to figure out where people are going and how to get more people there than any other choices we have, using our resources effectively and efficiently. I think though, when we look at the mission of transit agencies, maximizing ridership is an important element, but it's only one element. And I think when we look at the data needs for an agency, big data, small data, whatever data, it's really important to understand the mission, because the mission tells us what type of data we need, what are our policy objectives. And I think if we look at that, yes, we do look at big data, we do look at cell phone data, we look at the millions of data points that we collect on a daily basis from how people pay, from where people are getting on and off, to understand travel patterns and ridership. But it's probably equally important for us to look at trade-offs related to access and equity, making sure that we're providing services not just where it's most heavily used, but across the spectrum for the service we serve. Last September, we launched a service called OmniRide. It's a micro-transit service that's designed to sort of act like a TNC, like Uber and Lyft, and take people directly from an origin to their destination. When we launched OmniRide, with using the same resources as fixed route service before, we increased access to residents in Chino Hills by about 70%, from about 46,000 residents to about 80,000 residents. And here we can use Tableau and sort of the data we collect on a daily basis to sort of look at what our times of travel are, which are the bar charts on the right, where people are going. And then more importantly, for efficiency's sakes, we can look at where people are going by time of day and look to position the vehicles correctly.
All right, good morning, everyone. My name is Josh Landis. I'm the planning manager at Foothill Transit. I was looking at this topic of big data with the view of ridership. I wanted to focus on this discussion of equity. And so I wanted to hone in on one of our lower performing routes, line 197, that operates from Pomona Transit Center to Montclair, as a way to demonstrate how big data can give us a guiding path, but there's also some subjectivity needed. We look at census data as kind of another reference point. So the area that I have here, kind of highlighted with the red circle, is a high poverty area. And so the route serves a greater need to the community than just how many people ride per hour.
We also have a board-approved bus stop strategic policy, which the board passed that in 2015 as a way to try to maximize our limited resources. We have all of those bus stops that I mentioned, and every time you install shelter and a bench and a trash can, that takes a person to maintain those things, make sure that we keep them up to our standards, keep them clean, keep the trash changed, deal with graffiti and things like that. So we can't just put them out everywhere, because we would need a staff of, I don't even know how many people to be able to take care of that. About every 25 to 30 shelters that we deploy, we find that we have to hire a new stops and zones person to help us make sure that we maintain them. So the policy really aims to do two things. One is to maximize benefits. So to install these amenities at the busiest stops, the stops with the highest ridership, to make sure that most people are benefiting, but we also had to ensure equitable distribution. And when we look at that, we're looking at two things. We're looking at the geographic equity, so make sure that we're spreading it out among those 22 member jurisdictions that we have. And then also we're looking at social aspects, special needs, schools, senior centers, medical appointments, Things like minority and low-income populations. We're looking at all of those things to drive our decisions, and a lot of data is involved in looking at that.
So here we see a mapping of those 4 routes and the differences in change of ridership between 2018 and 2021. So for the first route, for Route 1, there was about 69% decrease between February and April 2020. For Route 19, it was about 59% decrease. For Route 15, about 68% decrease, and Route 27, about 67% decrease. So this is just all between February and April 2020.
So 2 important insights from these graphs. One, that there is significant room for improvement, right? We can see that on stop 75 on the top graph, stop 775 in blue, right there, it had an average departure time variance of about 5.5 minutes on Saturdays, whereas Sundays it was much more accurate, right? But secondly, and somewhat more interestingly, we can see that the variance follows a somewhat predictable pattern, right? So we're going to see how different algorithms can reduce the departure time offset with big data. So we can consider, things like peak hour of the day, route length, weather, bus speed, ridership numbers, etc. And this will allow us to find which external factors are kind of determining these patterns and affecting the dwell and arrival times.
Probably one of the most difficult laws to achieve is what's called Senate Bill 375. That's a state law that requires us to demonstrate how our regional plan, all of the investments that we're proposing in our regional plan, will achieve a 19% per person reduction in greenhouse gas emissions by 2035. And we have to achieve that reduction in greenhouse gas emissions by reducing vehicle miles traveled. So our strategy that we came up with for achieving these goals is what we call the 5 big moves. And the 5 big moves work together to create a complete mobility as a service transportation experience. And then next operating system is what we call the brain of the transportation system. This is really a digital platform that uses data to integrate modes of transportation and manage how the transportation system is used. It's really what makes the glue that keeps everything together, and it's what makes this vision for the future of transportation work. And then what can't be shown as a line on the map is the next operating system. But this illustration really helps to demonstrate, how it works. Essentially, it's a data exchange, right? It's ingesting data from smart infrastructure, from public and private transportation services, from apps, and then it's using that data to provide better real-time information to people traveling around the region, better tools, applications that would actually allow for, mobility as a service instead of having to have 6 different transportation apps on your phone. It provides operators with better information. So our transit operators can make changes to services more quickly, as opposed to waiting for static data sets to analyze. And then of course, for planners and policymakers like many of us, having access to this information makes our jobs much easier. We can identify solutions more quickly when we have access to real-time data. Under the 5 big moves concept, she'll have a lot of options. She could take a pooled ride, hail a rideshare vehicle, and travel in the express lanes and get there pretty quickly. She can take commuter rail, and her employer subsidizes her transit pass. So that's actually a free option for her, and it's quite fast. And she could choose to drive alone if that's convenient, and she can pay to use the managed lanes and pay to park. So that's the more expensive option. But Laura chooses the transit trip because it's fast and it's cost effective for her. So now Laura's son doesn't need to be dropped off at school because there's safe, complete corridor infrastructure, and he can ride his bike to school, and she gets a little notice on her app when he arrives there safely. She can use Wi-Fi on the train and get things done, like ordering groceries and having them delivered to a food locker at the transit station for her to pick up when she's coming home from work. And there's daycare in the mobility hub where she works, so she can have her daughter on the train with her and drop her off at daycare and then pick her up again before she gets onto the commuter rail in the afternoon.